So in this session, we're talking about threads. So what is threads? A thread is a small set of instructions designed to be scheduled and executed by the CPU independently of the parent process. For example, a program may have an open thread waiting for a specific event to occur or running a separate job, allowing the main program to perform other tasks. A program is capable of having multiple threads open at once and terminates or suspends them after the task is completed. A thread is a basic unit of CPU utilization. It comprises a thread ID, a program counter, a register set, and the stack. So in this figure, in a single threaded process, as you can see in this box, it is a process. So each process have its own code data files, which is its own resources. So a thread have its own register and stack. So for a in order for a thread to access the resources of a processor, the thread must undergo or go through the register and stack. That's the single threaded process. So in the multi-threaded process figures, as you can see, there are three threads, and each of those threads have their own register and stacks that access the processor's resources, which is the code, data, and files. And that's the indication and that's the figure of multi-threaded process. So types of threads. There is two types of threads: user threads and kernel threads. So user threads management done by the user level threads library. These primary thread libraries: POSIX pthreads, Windows threads, Java threads. So kernel threads supported and managed directly by the operating system: Windows, Solaris, and Linux. So single thread. A single thread also has the beginning, a sequence, and an end. At any given time during the runtime of the thread, there is a single point of execution. However, a thread itself is not a program. A thread cannot run on its own, rather, it runs within a program. So as I said, a thread is run within the program. So you can see all the threads here in. Let me show you how to show all the threads. Mhm. Task manager. So performance. So as you can see here, we have 4 cores and we have 1,396 threads and 102 processes. Handles 42,500 code. So it totals the all the threads that this operating system have installed. So each application have its own threads, right? So if you total all of the threads in this application, it would be 1,363 threads. So there is another thing I want to show you. Open resource monitor. Here in the CPU, you can see the threads of each application. See that? These are the threads. Their threads. So in OBS 64.exe, he have 33 threads. See, 33 threads. And how many threads. If you total all of this, it would be 1392. So each application have its own threads, or the threads run within the application. So kung mag-install ka ng bagong application or software, madadagdagan yung total of threads ng system. Kasi nga, as ang threads is within the application. So multi-threading. Multi-threading is a model of program execution that allows for four multiple threads to be created, with the process executing independently but concurrently. Sharing process resources depending on the hardware threads can run fully parallel if they are distributed to their own CPU core. So like for example, a word processor may have a thread for displaying graphics, another thread for responding to keystrokes from the user, and a third threads for performing spelling and grammar checking on the background. It depends on the core or CPU, so that when the system needs to access that kinds of function, it automatically switch them back. So this is how multi-threaded. As you can see, a threads come. So if the cores have four, so if the processor, if the CPU have four cores, a threads goes a threads can go to one core, and again another threads comes to the third core, then the fourth core, then the second cores. So as I said earlier, assigning them to each core in order for the application to work. So threads in the web servers. So web server is an example of multi-threading because as you can see, a web browser might have one thread display images or text while another thread retrieves data from the network. For example, one solution is to have the server run as a single process that accepts requests. When the server receives a request, it creates a separate process to service that request. So as you can see in this figure, so on accessing the web server or some URL link, a client access the server. So a client access the server and redirected to a certain website. But then again, another client wants to access the same website. So the server creates another thread for the new client to access the website. This goes so on and so on. Since the servers is creating threads for each new client or users that access to the website. However, the server that creates threads is not infinite. So someday it will run out of threads. It will run out of thread because it's not infinite. The problem here is that the thread pool of the website is it's on its limit. So it cannot create another thread for the new user. So example of this is the USM BLE website. So because of many students accessing the website, the website starts to crash and can't support the students because it cannot create another thread because it reaches its own limit. So that's example of multi-threading in the web server. So what's the benefits of multi-threading? So responsiveness. Res- Multi-threading and interactive application may allow a program to continue running even if part of it is blocked or it's performing lengthy operation, thereby increasing responsiveness to the users. So responsiveness, when you access an application, then you want to access another application, you can easily switch them back together, back and forth. Unlike the OS before that, in order to open new application, you have to close the current application. So because of multi-threading, you can easily access them back and forth, no? Back and forth. So you just have to either minimize the application, then click the other application. This happens because of threads. So resource sharing. Threads share the memory and the resources of the process of which they belong to the default. The benefit of sharing code and data is that it allows an application to have several different threads of activity within the same address space. So what this mean by this is that because of multi-threading in a processor, they can share its resources. What I said earlier is that on a processor, they have resources so that in a processor, two or more threads can access those resources. So economy. Allocating memory and resources for process creation is costly because threads share the resources of the process to which they belong. It is more economical to create and context switch threads. So what this mean by economy is the availability of a software of an application. So in order for it to access immediately, as I said earlier in responsiveness, you can quickly access the application you want by use back and forth. So this happens because of the threads blocking system are called block system. So uh in order for an in order for application to run, the user must have interact with it. So again, if the user wants to access another new application, then the threads switch or the thread switch by the use of call block scalability. The benefits of multi-threading can be even greater in multi-processor architecture, where threads may be running in a parallel or different processing cores. A single-threaded process can run on only one processor, regardless how many are available. Multi-threading on a multi-CPU machine increase concurrently. So what this mean by this is that because of the multiprocessor structure or architecture, the availability of multi-threading is so because of having multiple cores or multiple processor, the execution of the program is running on a parallel, not in a parallel in a parallel in a different processing cores. It looks like a zigzag. Parallel is like a zigzag in course. So a single-threaded process can run only one processor regardless how many are available, multi-threading or multi-CPU machine using concurrency. So it doesn't matter if you have one cores or multiple processor as long as it can execute or as long as the application can have a or threads built in it because what I said and threads is not a program, which means by that is that the threads is within the program. So since we're in a modern age, there is also newly introduced threading, which is the hyper-threading simultaneous multi-threading. So what is hyper-threading? Hyperthreading is a process by which a CPU divides up its physical cores into virtual cores that are treated as if they were actually physical cores by the other operating system. So example of this hyperthreading is AMD Ryzen Threadripper or Intel Core i9X series. So there are many hyperthreading cores. There are many different types of hyperthreading cores that are released today in the market. So what happens in the hyperthreading is that once a thread comes in, it will add an additionally one one process. So one thread comes out two threads or two process because one thread has become two threads because it acts as an the physical threads can add or can have its own course to a logical threads. So a one thread creates two logical two logical two logical threads that acts as a physical threads. So when the threads come in, it will show two process two tasks or function. So in hyperthreading, if your processor have two cores in so that I so if your processor have two cores, then it will process four different function or threads. So if your cores have if your processor have four cores, then each core have its own threads, but they add an additional one to each of the cores so that it will make two. So if there are four cores, then if you add four, then it will make eight. But now in hyperthreading, they have introduced 16, 32. So there are many thread cores that are introduced today. So multi-core programming. Earlier in the history, computer design in response to the need for more computing performance, single CPU systems evolved into multi CPU system. A more recent similar trend in the system design it is to place multiple computing cores on a single chip. So parallelism. Parallelism means that an application splits its task up into smaller subtasks, which can be processed in parallel for an instance. The instance on multiple CPUs at the exact same time. So, if happen your processor have two cores, then the execution or the runtime of the parallelism is that it goes in, as you can see in this figure, in core 1, the task comes in and then goes to the task 2 comes to core 2. And then if another task is being implemented, then it will go to core 1 and then add into it core 1. And then if again and the new task was implemented, then it will go to task 4 and so on so forth. So parallelism does not require two tasks to exist. It regularly physically runs parts of tasks or multiple tasks at the same time using a multi-core infrastructure of CPU, but assigning one core of each task or subtask. So concurrency. Concurrency means that an application is making progress on more than one task at the same time, concurrently. Well, if the computer only has one CPU, the application may not make progress on more than one task at exactly the same time. but more than one task is being processed at a time inside an application, it does not completely finish one task before it begins the next. So in concurrency, if that task is implemented, then it does not exactly execute another task. More likely, the task that first implemented is not completely finished, then the second task will not be executed. So this part, the task is being what so the tasks that are currently used will be more important than the second task. So what this mean by this is that the second task that does not have related function to the application that you're using is not being used. So the task that was not being that the task that was not helpful was put on hold. So programming challenges. The trend towards multi-core systems continues to place pressure on system designers and application programmers. To make better use of multiple computing cores, designers of operating systems must write scheduling algorithms that use multiple processing cores to allow the parallel execution shown in Figure 4.4. For application programmers, the challenge is to modify existing programs as well as design new programs that are multi-threaded. In generally, five areas presented challenging for programming of multi-core system. So yeah, writing multi-threading multi-threading OS is so hard. You can't you can't totally read the code when you code a multi multi multi-threading OS because your code is a total mess. You can say else while else if a lot of that and so on so on. So these are the challenges. Identifying tasks. This involves examining application to find areas that can be divided into separate, concurrent tasks. Ideally, tasks, tasks are independent of one another and thus can run in parallel on individual cores. So, identifying tasks is you're examining the application where the application have its different subtasks and then assign them to the most suitable functions or interprocessors. Those can run in parallel or run concurrent running. So balance. While identifying tasks that can run in a parallel, programmers must also ensure that the task performs equal work of equal value. In some instances, a certain task may not contribute as much value to the overall process as other tasks using a separate execution core to run that task may not be worth the cost. So balance. While running your application in a parallel or concurrent, programmers must also ensure that the tasks that are going to be performed are equal to work of equal value. So 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 in some instance other tasks may not contribute to the current contribute to the current con- for the current execution will not be current execution will not be shown unless Then the user implement a new task so that the processor can execute it. So the balance is the balance is there, since maintaining the balance between assigning the threads to its suitable functions so that it can run smoothly or at ease. So data splitting. Just as applications are divided into separate tasks, the data accessed and manipulated by the task must be divided to run on separate cores. So data splitting. So just as application, they divided into separate tasks so that they can access the resources in the processor. By doing this, they can easily access the resources because they are already placed in the system, which in the processor, which means that anytime, anywhere, they can you can access it immediately. Data dependency. So data dependency, the data accessed by the task must be examined for dependency between two or more tasks. When one task depends on data from another, programmers must ensure that the execution of the task is synchronized to accommodate the data dependency. So in order for the in order in order to work with uh, data dependency, the programmers must create or execute a task that is synchronized to accommodate the data dependency to the processors, examined examined and tested, so that when one task depends on data from another. So testing and debugging. When a programmer is running in parallel or multiple cores, many different execution paths are possible. Testing and debugging, such as concurrent programs, is inherently more difficult than testing and debugging single-threaded application. So, as I said earlier, coding a coding a threaded application is so hard. So, while debugging it is so confusing because you can't totally read the code because it's not readable. In so testing and debugging it will be different execution paths are possible. Because of these challenges, many software developers argue that advent of multi-core systems will require an entirely new approach to design software systems in the future. Similarly, many computer science educators believe that software development must be taught with increased emphasis on parallel programming. Because because of these challenges, so, so software programmer or developer must want to implement or to know more about parallel programming, since it is in, more more interactive or more interactive on multi-core system. So a new design approach would be a good implementation coding so that programming a new operating system will not be so hard if you focus on parallel programming. So types of parallelism. Data types parallelism and task parallelism. So data parallelism focus on distributing subsets of some data across multiple computing cores and performing the same operation on each core. Consider, for example, summing the contents of an array of size n on a single core system. One thread will simply sum the elements 0 n minus 1 on a dual core system. However, thread A running on core 0 could sum the element 0 n divided by 2 minus 1, while thread B running on core 1 could sum the elements NA 2 n minus 1. The two threads would be running in parallel on separate computing cores. Task parallelism involves distributing not data but tasks threads across multiple computing cores. Each thread is performing a unique operation. Different threads may be operating on the same data or they may be operating on different data.